Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to be working to determine whether a linear expression is a factor of a polynomial function. And the thing to remember here is that if x minus k is a factor of f of x, then that means that k is a 0 of f of x. And if we think about synthetic division, that means that the remainder would be 0. So if I want to find whether x plus 4 is a factor of this first polynomial, I need to do synthetic division with k being -4 and examine the remainder. So I'm going to list my -4. The largest degree term is x to the 4th. And I've got an x cubed, an x squared, an x, and a constant. So we're ready to go. Copy down those coefficients of 2, 8, -7, -19, and 36. And we'll do the synthetic division. Bring down the 2. -4 times 2 is -8. 8 plus -8 is 0. -4 times 0 is 0. Add that column. -7 plus 0 is -7. -4 times -7 is positive 28. -19 plus 28, that's a positive 9. And then finally, -4 times 9 is -36. 36 plus -36 is 0. Because that remainder is 0, k equals -4 is a 0. And x plus 4 is a factor of f of x. Now, if we were trying to find all the zeros or all the roots of that function, because we know that x plus 4 is a factor, we can, and we have, divided it out, and we could worry about the remaining function, which was 2x cubed minus 7x plus 9, and we would go after that one next. More on that in a later video. So I'm going to try the same thing, also x plus 4 with -3x cubed minus 7x squared plus 8x minus 55. So -4 again. This time our largest degree is 3. So I've got x cubed, x squared, x, and a constant. So no skipping. -3, -7, 8, and -55. Bring down the -3. -4 times -3 is 12. -7 plus 12 is 5. We totaled the column. Do it again. -4 times 5 is -20. Total the column, -12. Do it one more time. -4 times -12, that's positive 48. -55 plus 48 is -7. That tells us that k equals -4 is not a 0 of f of x. And that also tells us then that x plus 4 is not a factor of f of x. Let's take a look at one more example in this video. I want to factor this polynomial function, 3x cubed plus 4x squared minus 148x plus 96, given that 6 is a 0. So again, 6 is a 0 tells me x minus 6 is a factor. So I know that my final expression is going to have x minus 6 times something. But I can do synthetic division to take that third degree factor down to x minus 6 times some second degree expression, and then I'll try to factor that. So long division, 6, 3 for x cubed, 4 for x squared, -148 for x, 96 for the constant term. And again, my remainder here should be 0 according to the fact that I know that x minus 6 is a factor. That 6 is a 0. Bring down the 3. 6 times 3 is 18. Total the column to get 22. Multiply. 6 times 22 is 132. Total the column. Negative 148 plus 132 is negative 16. 6 times negative 16 is negative 96. 96 minus 96, 0. So I've got x minus 6 times 3x squared plus 22x minus 16. That is the factored form of f of x. Now we would also, we should try to factor this quadratic part, and this one actually factors as well. 3x squared, there's only one way that you can get 3x squared, and that's by multiplying x by 3x. And if I use plus 8 and minus 2, that actually works. X times 3x is the 3x squared, and 8 times negative 2 is the negative 16. What I really need to check is, do I get the middle term? And 8 times 3x is 24x, and x times negative 2 is negative 2x. 24 and negative 2 make a positive 22x. So that is the factored form. Let me hide some of this. We divided by x minus 6 to take that third degree function, which we don't really know how to factor many of those, down to a second degree polynomial, which we have experience with. All right, that's it for this video. I will see you in the next one.